Yesterday, we focused on the probability of events and how to represent that as impossible or certain or anything in between on the number line. Today, we're going to continue looking at probability of certain events occurring and how we can represent them as fractions, decimals, or percents. So if we look at this problem below, it says that a student brought a very large jar of animal crackers to share with students in class. Rather than count and sort all the different types of crackers, the student randomly chose 20 crackers and found the following counts for the different types of animal crackers. Estimate the probability of selecting a zebra. So just looking at the problem, we do also have three other questions below it that we need to determine the probabilities of. So if we're talking about first selecting a zebra, I'm going to first look in my table to see how many zebras were actually found. So if I go ahead and highlight, I can go ahead and list that if we are caring about the zebra, we want to know how many zebras were found and compared to the total number of animal crackers. So I see that once I've highlighted that row, that there were 3 zebras out of a total of 20 animal crackers. So the probability of selecting a zebra is 3 out of 20. Okay, so that one wasn't given to us below, but it was already said in the word problem, so it's good to start off there. So we're going to practice a few more examples because it seems pretty straightforward, and yet sometimes wording can get a little tricky. So let's check out another example. It says, what is the probability of selecting a monkey? Well, we also have a monkey in the table to use. So I see that here, there were 4 monkeys found. So let me go ahead and set up my fraction compared to how many total animal crackers again? 20. So that means the probability of selecting a monkey is 4 out of 20, but I also know I can simplify this fraction by 4 and get 1/5. So I could also say the probability of selecting a monkey is 1/5. I know that yesterday we talked about how we can convert 1/5 to a decimal using bow tie, and we get 0.2. And then I also know that we can convert a decimal to a percent using Dr. P, which would make it 20%. So any of these numbers can be used to answer this question. So the probability of selecting a monkey is 0.2 or 2/10, or we could also say 20%. Let's try the second question. What is your estimate for the probability of selecting a penguin or a camel? So I'm going to go ahead and write penguin or camel compared to the total number of animal crackers. So in this case, we're okay with both animals. So I'm going to highlight penguin and a camel. So I see that there are 3 penguins and I see that there is 1 camel. So I'm going to combine them, which I know is 4, right? 4 total options, and the total is still 20 animal crackers. So we get a probability of 4 over 20, which in the earlier example we just did is the same thing as 1/5, which is the same thing as 2/10, which is the same thing as 20%. All 4 of these numbers are equivalent, therefore they all represent the probability of selecting a penguin or a camel. Awesome, so far so good. And the last question is that we are looking at if there are 500 animal crackers in the jar, approximately how many elephants are in the jar? So in this case, we are using the information from our table to predict how many would be in a 500 animal cracker jar. Because if you see in our table, we only have a total of 20 animals. So if we have elephant compared to the total, I see, let's go ahead and highlight where I see it in my table. It is 5 out of 20 total. But they want us to use this fraction to predict for a total of 500 animal crackers. So I can actually use this proportional situation, right, to figure out what is missing, right? Because this is a ratio, and I want the ratio to stay the same even if it was a total of 500. So I know the total goes below. So 500 is the total here. And we are missing how many elephants would belong to this 500 animal cracker jar. So I'm going to use E for elephant. And how do we solve our proportion again? Well, we know we can cross multiply and divide. We also know that we can use a scale factor to determine how we get from 20 to 500 proportionally or multiplicative in a multiplicative relationship. So I'm not quite sure what number we're multiplying to get from 20 to 500. So I'm going to go ahead and divide 500 by 20. And I see that 20 goes into 500 two times. Bring down the 0, 20 goes into 100 5 times. So we are multiplying by 25 to get from 20 to 500. That is our scale factor, which means we have to do the same thing to the top. So if I multiply 5 times 25, I know that I get 125. So E is 125, but what does E represent again? Elephant animal crackers. Animal crackers. And so this is another example of how we can use probability in a proportion in order to create equivalent ratios. So remember, we predicted that there would be 125 elephants because this would keep the ratio of elephants to the total number of animal crackers the same as the one we have in our table. Excuse me. When finding probabilities in a table, we need to remember to write the number of occurrences over the total number of occurrences as a fraction, and then we can simplify. We can also use this fraction to set up a proportion to predict if the total number of occurrences was different, what would then be that specific occurrence that we are looking for, like we did here for the elephant animal crackers. Let's try some more on our own.